The part 9 is nothing but discussing about the binary tree and its traversal. Okay, we know what is. Yes, tell me what is binary tree. Having at most two children. Yes, very good, Manoj. Yes, we can have 0, 1 or 2 children. Okay, so this is the binary tree. Okay, and also discussing about traversal. How many traversal we have studied already? Yes, pre-order, post-order, in order and level order. Okay, we are going to implement the particular concept in program. What is the problem statement here? The program must accept n unique integers and an integer k as the input. Okay, the given n integers must be inserted into the binary tree level by level. Okay, we are going to insert the element level by level. In each level, the data must be inserted from left to right. Okay, these are the concepts we are going to implement. Then the program must print the pre-order, in-order, post-order. We are going to print these three order, pre-order, in-order. We know already what is in the pre-order and what is in the in-order and what is in the post-order, right? So then the program must print yes. Also, we are going to search a element. Okay, we have to give one key. Particular key is present in the particular tree. Then it prints yes. Otherwise, no. Okay, this is the problem statement. What is that? We are going to get n number of integers. Okay, we are going to implement. I mean, create a binary tree. Insert the element left to right, and so the level by level. Once the zeroth level is completed, then only we can come to the next level. I mean second. Okay, we know right what is my level. The level is 0 means only one element, one node in the particular tree, that is root node. If the level is uh, 1 or 0, anything it may be. If it is the level is 0, then root element is only present in the particular tree. If the level is 1, then we can have at most 2 children. Okay, is it clear? And the level is 2, then how many children we have at most? We can have, level is 2 means at most how many child we can have? 4. Yes, then level is 3 means level is 3, third level. How many elements, how many nodes at most we can have? 8. Okay, not 6, 8. Like that it's going. Okay, so we have to find which level we are here. Okay, we find out the level. Based on the level we can insert. For example, if the level is 2 means, then I can insert up to 6 sorry 0, 2 and 4 elements. Okay, 4 elements I can 4 nodes or 4 elements I can insert at the particular level. So I have to find the level, and from the level I can find out the maximum number of elements I can insert. Okay, compared to the maximum level, each and every time I can insert one element and compare both the inserted element and the maximum element. Once the maximum number of elements and basic levels, I mean basic nodes, how many nodes we have inserted already. Okay, both are compared. Once both are same, then what is the procedure? I can insert the height by 1. I mean, next I am going to the next level. Okay, this is the concept we are going. Yes, 2 power h. Yes, okay, this is a concept we are moving. So we'll see how we can implement. Any idea? Before that, we see first what is my binary tree. Just try to recall the binary tree. Okay, this is a binary tree. You can have at most 2 children, 0, 1 or 2 children. Okay, this is the binary tree we know. And traversal we know. In order means left, root, right. Okay, pre-order means root, left, right. and post order means left right route. Okay, these are the concepts we have to know before entering into the particular program. Okay, now they are giving the boundary conditions and input format. This case nothing but the element we are going to search. Okay, see the output here. Before that, before going to a program, you please manually try this diagram. I mean, create a binary tree. Then only it is easy for you. This input, number of integers. Okay, number of nodes in the particular tree. Okay, 10. Okay, so we are giving the 10 elements, and this is nothing but what? Searching. We are going to search element 9. Okay, for this the input is, first we have to create a binary tree for these elements and print the pre-order, post order, in order, and again if the element is present, then we can we have to print as yes, otherwise no. Okay, this is the input output. Is how we can implement. Any idea? Binary tree, first we have to insert the root and move to the left and right. After that, we have to increment the level or height. Okay, increment the next level and insert from the left, right, left, right. Okay, like that we are going to do. Create a structure, and it is for creating a node. This function is for creating a node. Okay, we have to check the nodes count. Okay, for that we are using two variables here. One is last level nodes count. Okay, this is nothing but level count, nodes count. Okay, no, we can say this is nodes count. Okay, how many nodes we have inserted already. Okay, this is the nodes count. And another one variable they are using, that is max last level nodes count. We can say max nodes count, how many nodes at most we can have at the particular level. Okay, for that they are using the max last level nodes count. Okay, so these are the two variables. It is somewhat new to you, otherwise the remaining things are the same. Okay, insert means we are going to insert the element. If it, the particular height is equal to -1, otherwise we can say this is the height equal to 0, no problem. Okay, we can say the height equal to 0, then we have to create a root node and incrementing the height. Okay, so after that, once the particular level is completed, for example, nodes count in short form, I have I can say this is the nodes count. Nodes count. How many nodes we have inserted already? Okay, this is the maximum count at this particular level. How much I can insert at most? Okay, this is the max nodes count. Compared to these only, we are going to insert each and every element. Okay, both things are equal, then what is the meaning? Particular level is completed, particular level is inserted, then we have to move to the next level. Okay, this function is for what? Inserting a node. Once the particular level is filled, the level 2 is filled means automatically we have to make the particular level nodes count as a 0. Okay, why means we are moving to the next level after that, right? So in next level we have to start from the what, 1 2 3 4, at most 8 elements I can have. Okay, once the third level is completed, then I move to the fourth level. For that also I have to make the nodes count as 0. Starts from 0 to I can have at most 16 elements. Okay, like that we are going to do for that. This is the insert function. This is nothing but the one new function. This is nothing but max level, max nodes count, how many nodes at most we can have. Okay, this is the, for that we are using this variable. In that they are doing, how they are calculating the maximum count means, one, this is nothing but left shift operator. Okay, this is nothing but left shift operator. It is used to move the element. I mean, here they mentioning that the element 1 is, okay, shifted to the left side. based on the height. If the height is 1, I can shift the particular element by one position. Otherwise, the height is 2, then I can move the particular element 1 in 2 position. For example, I will for example, we have here we are going to represent the particular value 1 in the form of binary format. Okay, binary form. What is the binary form for the number 1? How we can represent the 1 in binary form is 0 1. That means we can say 0 0 1. Okay, in the decimal. Okay, then left shift operator is nothing but we have to, here they are mentioning the element 1 is going to we are going to implement the left shift operation on the element 1. That means in second line, if it is based on the height, here in this program we are having that one left shift of height. Okay, please here assume that a particular height is 2 means we can represent this way. Is it so? Height is 2. This is equivalent to 2 in the form of binary, right? So we make the left shift means what is the meaning? In the first we have to make 2 shifts based on the height we can do. Okay, so now the in the first shift the value changes to like this, just the element 1 is moved left in one position. Okay, this is the first shift, and second shift how we can do this way. This is equal to what? This is equal to what? Is it 4 1 0 0 0 8, not 4? Okay, so this is equal to 8. From that we can assume that in the after the incrementing the height, that means here the height is 2, once we are incrementing the height is 3, and that position at most we can have 8 elements. Okay, we know manually we know how we can calculate the height and how we can calculate the maximum number of nodes we can insert, but the system doesn't know, right? For that we are using this concept. Okay, we can use many any other different concept, no problem. Here they are using like this. Okay, based on this they are finding the max count. Okay, based on this operation they are finding the max count. After this they are comparing both the nodes count and maximum nodes count. Both are equal, then what is the meaning? Both are equal, then what is the meaning? The levels completed, the particular level, okay, the particular current level is completed. We have to increment the level by 1, that is height is incremented. Okay, then we have to find the this is what already the Santosh said, right? 2 power, like the maximum number of count multiply with 2. Okay, once the level is incremented, then next, what is the next procedure? We have to assign the particular nodes count as 0. Okay, because now only started with the next level, new level is started, so we can insert from the first position, left right, like that we can have at most what 16 elements. Okay, this is the way we are going to implement this finding the number of nodes we can have at most. Okay, okay, here the next is nothing but, next function is nothing but it is for finding where I can insert, whether I can insert the left side or right side. Okay, we are what is the concept in the problem statement? We can insert from left to right and level by level. Okay, now we are at the third level means, okay, at most you can have what, how many elements? 8 elements, right? So in that, where I can 8 positions we can have in that, where, how can I find which position I can insert now? For that they are using this function. Okay, insert level order into data. Data is passing, and node data is nothing but we are going to insert the element which are going to insert into the particular tree. Okay, based on the we are inserting, these are the arguments, data and the particular structure, and last level nodes count and max level nodes count. Based on this only we can find where I can insert the particular current position. Okay, last level nodes count mean, for example, we are at the level 2. Okay, we are at the level 2 means at most how many elements we can have? Level 2. Level 1 we can say is the root. Level 2 means how many elements we can have? 2 elements, right? Is it so? Yes, 2 elements we can have at most. Okay, so max nodes count is 2, and last level we can take another one, I mean level 3. Okay, then only easy for you. Okay, now I'm taking my level is 3. So how at most how many elements I can have? 8 element. 2 power 3 is a 8 element. Okay, here the value is 8. For example, I'm assuming I'm in the level 3. Okay, so the max node count is 8, and the last level node counts is what? This is nothing but the element which are inserted already. Okay, for here please assume just we have inserted 2 elements. Okay, 2 elements we have inserted, but we can have at most 8 element. Okay, further we can insert 6 elements. Okay, in that particular level 3. Okay, for that how we are checking where I can insert means, we are just dividing the max last level count by 2. Okay, this is assume here this is the 8, and 8 divided by 2 is 4. Particular 4 is greater than the last level count means, what is the meaning? The particular 4 is greater than means, what is the meaning? We have to insert at the left side. Okay, we have to insert at the left side, otherwise we can go to the right side. Okay, the last level node count is nothing but the elements which are already inserted into the particular tree. For example, it is maybe 2 means already I have inserted the level 3. I am in the level 3 now. I have inserted 2 elements only, so we can have at most 8 elements, so 6 more elements I can insert. So here how we can calculating means, divided by 2, that is 4. I'm dividing the particular max count into half, that is divided by 2, that is 4. It is in the middle position, it is pointing to the middle position. The particular I'm inserted, then elements which are inserted is 2 so far. 2 less than 4, 8 by 2, that is 4, right? The 4 is greater. So what is the meaning? I can insert at the left side. Here some more places are there, so we can insert at the left side. For example, the nodes count is greater than the particular max by 2 means, what is the meaning? We have to insert at the second half. Okay, this is the meaning. So this is if it is lesser than, we can insert at the left side, otherwise go with the right side. Okay, this is the concept. Remaining things are not complicate. That is we are going to pre-order. That is, this function is used for printing the elements in pre-order. Okay, how we can pre-order? We know what is pre-order. Root left right, print of data, node of left, again calling the same procedure, pre-order. Again the function is recursive function. Okay, I'm moving to here, then not equal to null, go with the left node, and again the same process, like that it is repeating. First we are printing the root node. Okay, please manually you please check with that, with these elements you draw the binary and travel with the pre-order, post-order, and in order. then you check with that program also. Okay, and this is for in order. In order means left, root, right. We have to first print the left value. Okay, print in order of, this is the function, this is not printing statement, this is a function. It is calling itself, that is a recursive function. That means left of, left of, left of, like that it is moving, right? So it is a recursive function. You have to print the left node and print the actual root data and right child. Okay, and next one is the post adder, the same procedure, and searching the element. Particular element is the node is not equal to, then we can do search, and the particular data is equal to k, then return one. Otherwise you have to find in the both left and right child. Okay, so checking with the root node, it is same, then return one. Otherwise go with the left child, I mean left subtree. Okay, and return the value. Otherwise both are false, then I can go with the right subtree. Okay, this is the binary tree implementation. Is it clear, everyone? This is the binary tree implementation. Okay, next one is binary search tree. Wait a minute. One minute. Next one is part 10. It is discussing about binary search tree. Okay, Aditya, have you completed the part 10? Is Aditya is there? Have you completed part 10? Okay. What is the binary search tree? Yes, Aditya is there. Aditya, have you completed the particular part 10? It seems like. Yes, what is my binary search tree, pa? Students, what is my binary search tree? What's the concept? Arranged in specific order. Okay. So this is a concept we are going to implement. Okay. So we'll see first what is my binary search tree. Okay. Binary search tree is okay, Isaac. Isaac, why you're not completed up to part 7? You're lagging in many parts. Why, Isaac? What's the problem? Yes, Isaac, respond me. What's your problem? Why you are not completed? Having some problems. Okay, when you can complete? Hmm? Binary search tree is nothing but the elements are arranged in some order, right? The left subtree having the elements which are lesser than the root, and right subtree having the elements which are greater than the root. Okay, so we can do the search operation. Okay, how we can search? The same procedure. We have to search the root first, then the particular element is lesser than the root, then we can go with the left subtree, otherwise go with the right subtree. Okay, and insertion, how we can insert, we know, right? First we have to insert the root node, and based on that we can insert other elements that is lesser than, then we go with the left subtree, otherwise right subtree. And how we can find the minimum value means, how we can find, we can go with the leftmost element. Okay, left child, like that we can go, then we can find the minimum element. If we want to find the maximum element, then we go with the right child. Okay, and the main process here is deletion operation. How we can delete the particular element in the binary search tree? Three cases are there. Deletion of a node having no child, one child, and two child. The particular node doesn't have any child, then what is the process? We just directly eliminate the root particular node. Okay, the element which is we are going to delete, which element, the element we are going to delete is having only one child, means what is the process? We just replace the particular node with a child element, then delete the root key. Okay, the third case, deletion of node having two children, then how we can delete? Deletion of a node having, okay pa, yes, in binary search tree, how we can delete a particular element? Anyone? The element we are going to delete is having two children. Okay, then how we can do the deletion in binary search tree? Anyone? Anyone? Are you following? Replace the root node with max element or min element. Max element means, any other answer, students? Make right child as root. Is it so? Yes, any other answer? how we can delete the particular delete any node in the binary search tree which is having two children. Make right child as yes, yes, this is the answer. Min value in the right subtree or max value in the left subtree. We can go with two ways. Anyone you can choose. We can replace the particular element with minimum value in the right subtree or maximum value in the right left subtree. Okay, this is a concept for deletion in binary search tree. Don't forget deletion in binary search tree. How we can particular element having two children means we can replace with two ways. One is deletion of a node. Sorry. Okay, I'm going to delete the element 15 here. How we can delete? I can replace with the child. Which one I can replace? Yes, I can. If I'm choosing the right subtree, I can choose the minimum element. Other, if possible, I go with the left subtree. Then I need to replace with maximum element. Okay. Here in this case, which one is the minimum of right subtree? 16. So I can replace the 15 with 16 and delete the particular node. Otherwise, if I come with go with the left subtree, then I need to replace the root element with what? Maximum of left subtree, that is 12. This is the left subtree for the element 15. So I can replace with the 12 and delete the 15. Is it clear? This is the way only we can delete in the binary search tree. Okay. No child and only one child, no problem. We can simply do the operation. If it is having two children, then we have to find what whether we can go with the right subtree or left subtree, no problem. If you are going with the right subtree, you have to choose the minimum element from the right subtree and replace with that particular node. Otherwise, if you go with the left subtree, you need to select the maximum element from the what left subtree and replace with that. Okay, is it clear? This is the deletion is binary search tree. This is the process we are going to implement in this program. Insertion, deletion is okay. Now we are we'll see the particular program binary search tree. This is the part 10. Okay, I'm explaining here now. You please, all of you, try to complete up to part 10. Okay, now part 9 is up to part 9 completed. So you have to complete all the programs. Hereafter, I will recheck. I will check the status again, and tell you and push you to complete. Please don't don't do like that. Please, you itself try to complete and update me. Then it is easy for you, easy for me. Okay, so binary search tree, we know the concept. What is how we can insert the binary search tree? Based on the order we can arrange, and how we can do the insertion, how we can do the deletion, everything we know, and the traversal also know, right? So the program must accept n integers. Okay, n queries as input. The program must form a binary search tree on the queries. The queries can be query type is one. Then the program must insert the following integer to the binary search tree. Okay. We can here we are going to follow the three cases. That is one is inserting and deleting. Third one is what? Pre-order traversal. We are going to perform the pre-order traversal. Okay. Here they are mentioning the condition. It's the input and output. Okay. So the three cases are there. One is what this is nothing but number of integer. Okay, how many nodes at most we can have in the particular tree. This is n, and in one is nothing but for inserting. We are inserting the element 10 and 5 and 20 and 1, 8, 15, 25. These are the element we have inserted with the help of this condition. The case is 1. Okay, in left side they are giving us 1, right? This is the means case 1. Case 1 is nothing but inserting the element just inserted. Case 3 is nothing but what? Case 3 is nothing but what? Pre-order traversal of the particular tree, binary search tree. Okay. So here Up to this inserted elements are inserted. Then number 3 is nothing but is for traveling pre-order this way. Okay. Then after that they are going to delete the element 20. Now the element 20 is deleted here. Again pre-order traversal. So after deletion of 20, the elements like this, and okay, then again deleting another one element 10 and displaying the elements. Okay. This is a sample input output. Okay, here also the same concept, the start node, left child and right child, root node, and create function is nothing but is used for creating the node. Inserting the element, how we can insert the current node equal to null, then create the root node. Okay, otherwise the particular data is what, lesser than the current node of data. Okay, the data is current node of data is nothing but the particular root node. Okay, current node is nothing but the root node, the data is nothing but here the root node. The data is less than the current node of particular data, then we can insert the element in the left side, right? It is lesser means we can insert at the left subtree. Okay, the current node of left not equal to null. Insert of current node of left comma data, they are inserting the element in the left side. Data lesser than current node of data, then current node of left, again we are checking this recursive, right? First checking the root node and left child, root left child of the particular root, again taking the left child as a root and checking with the data whether the particular going to insert data is lesser than the left child. Okay, if it is lesser, then I can insert a particular element. Okay, current node of left data, otherwise left equal to create node. Okay, no left child means we can create at the left child, create the particular new node as the left child, otherwise we have to move with the left subtree, again checking the same condition, particular data is lesser than greater than the particular data. Okay, particular node already we have. Okay, this is the concept, the same as a simple concept only, and otherwise we go with the right subtree. It is very simple binary search tree. We checking the condition. Okay, particular data is greater than less than. Based on that, we are inserting the elements. Okay. Next, pre-order traversal. Already same concept we have discussed in the binary tree, recursive function. Just pre-order means root left, right. So root first printing the node of data and pre-order traversal of node of left. What is the meaning? Recursive function, again calling the same function, doing the same process. Okay, frequently doing this function up to reach the node of utmost node left child. Okay, like that it moving. Once it's completed, come to the root and going to the right side. Okay, and get min value, where the minimum value placed in the case of binary search tree, how we can get the minimum value. Yes, in the case of binary search tree, where we can get the minimum value. We know what's binary search tree and how the data are arranged. Then tell me where I can get the minimum value. Yes, left subtree, leftmost child is very good. So how can I fetch the leftmost child? How can I get current node as a root assigned and current node of left not equal to null, then I can move the current equal to current of left. Okay, like that we need to travel and print the current data. This is the get min value. Just we are traveling in the left subtree. Okay, current node as the root and left is not equal to null, then we get the left child. Okay, until this is the while loop. Okay, until current node of left not equal to null, we are doing the same process and finding the minimum value. Okay, and delete the node. How we can delete? the element we are going to delete on element means we have to check with the root node. The element which are going to delete is lesser than the root node, then go with the left subtree, otherwise right subtree, like that only, right? So root equal null, then return root. Otherwise, the data is less than root of data, delete in the again the same function delete node. Okay, this is the function again calling. Okay, data is lesser than root of data means we have to come with the left child, I mean left subtree. Again calling the what procedure, delete node, same procedure, and particular node is a root and finding the same procedure. What particular node is the root and finding the left child, right child. Likewise we are comparing to find the particular data. After that we can delete. Okay, data is greater than, go with the right subtree. Again, if else spot, what they are doing, root of left equal to null. What is the meaning? This is the concept I have explained already. There's a deletion in binary search tree. If there is no child, no problem. Only one child means we have to replace with that particular child as a root, okay, and delete the root. If it is not both a child means we can select the minimum value from the right subtree or maximum value from the left subtree, then replace and delete. Okay, here else part they are explaining what root of left equal null. What is the meaning? Root of left equal null means only one child, that is root. So, sorry, only one child for that particular node, that is right child. Okay, root of left equal null means there is no left subtree, there is no left child. So only one child is there, that is right side. So I just move the particular right subtree as temp and assign the particular child node as a temp and replace with the root and delete the temp. Okay, this is the concept. And else if root of right equal to null means root of right mean no right child. So what is the meaning? Only left, only one child is there, that is left child. So we just doing what? Just assign the value into temporary, okay, and free the root value and assign return the temp value. Okay, temp is nothing but which is what? The child of that particular node, which node we are going to delete. Okay, I'm going to delete the element 20 means that is the root node. I have to here the root of right is equal means particular 20 doesn't have any right child. What is the meaning? Only one left child only is there. Okay, this is the meaning, right? No right child means it is having the left child. Okay, this is the concept. So here mm, we are just doing what? With the help of free variable, just deleting the root node and assigning with returning the temporary variable. This is the child of the particular node. Okay, this is the first case and second case. First case is nothing but empty. Second case is nothing but only one child. The third deletion is nothing but what? Having two children. Then how can I go with? Either I can choose the right subtree or left subtree. If I go with the right subtree means I can select the minimum element, left subtree means maximum element. Here they are doing only one concept, that is right subtree. We go with the right subtree. If I'm going with the right subtree, what is the meaning? I have to select the minimum element from the right subtree and replace with a particular node. This is the process they are did here. Okay, get the minimum node from the right subtree and replace and delete the particular element. Okay, checking the condition whether the input is in boundary. There are three cases are there. Case one is for inserting and case two is for deletion and third one is the traversal. Pre-order traversal only we are it. Okay, this is what binary search tree and its function. Okay, is it clear everyone? What Santosh? Recursive traversal? Yes, traversal means we can go with only recursive, right? Pre-order traversal here. This is the recursive function. We are calling this function in main function here. What's those for finding? Finding the leftmost child, madam, and for other traversal tree. Leftmost child also we are using the recursive function, and traversal also pre, post, in order. Everything also we are following the recursive function only. And other than that, what you are asking, I don't know. Okay, pa. Okay. And the next program is what? AVL tree. We know, right? AVL tree and its operation, rotation, we know, right? 1 minute. Mm, AVL tree. Aditya, yes. Shall I go with the 11th program? That is nothing but AVL tree. We know the AVL tree concept, right? The elements, how the elements are arranged in AVL tree, the same format which we are following for binary search tree, right? Elements in arranged in some order. But here again, we go with another one step, that is balancing factor. You have to check the balancing factor. That is, balancing factor is nothing but height of left subtree minus height of right subtree. Okay, we have to find that particular factor. Factor should be in 0, -1 and 1, then no problem. Otherwise, you have to make some rotation to make the particular tree is balanced one. Okay, is it so? This is the ABL tree. We know the left LL means we should make the what, right rotation, and RR left rotation, LR and RL. Okay, what is the difference between LL and LR? Yes, students, what is the difference between LL and LR? ABL tree. How we can do a single rotation and double rotation? Yes, very good, Sandeep, thank you. So single rotation we can go with LL and RR. LR and RL are the double rotation. That means we have to make two rotation. LR means we have to make first right rotation, then left rotation, and RL means like that, R and L. Okay. So this is the difference. How we can implement this rotation? Any idea in AVL tree? This is the AVL tree. Based on the factor, we are just arrange the tree. Okay. This is the rotation RR, LL, LR, and RL. RR rotation means it is in the RR means it is a right skewed tree. Okay. RR case means we have to make the left rotation. And LL means the tree in the form of left skewed. The elements only stored in the left side. We have to make the rotation and make the tree is a balanced one. And left to right, which the tree is in the form of left right. Okay. For that we have to make two rotation. First we have to make the L side. We have to rotate the tree by L side and right rotation. Otherwise, in short form, how we can do in the case of LR, the third element LR in the form of LR, the third element should come in the place of what middle element, and if it is placed in the middle, then which one is the left and which one is the right we know, right? This is the from process. This is the way we can implement the LR and RL also. Insert operation, the based on the what order, sorting order, we can insert the element. If you are going to insert mean, the element should if you are going to insert means we have to check with the root node. The element is lesser than, then we go with the left child, and otherwise go with the right child. Like that we can compare and insert. After insertion, each and every insertion we have to check with the balancing factor. If it is not balanced, and that to make we have to make the rotation and make the tree as a balanced one. Okay. And deletion, how we can delete, the same procedure used in the binary search tree, right? So this is the concept we are going to. After deletion, each and every deletion you have to do that balancing factor. If it is not balanced, then we have to make the rotation to balance one. Okay. So now we please go with the program. AVL tree. The program must accept any integers as input. The program must insert the integers into the AVL tree. Okay. We are drawing or creating an AVL tree. The program must print the rotation performed during balance the tree, and at last the program must print the pre-order traversal. Here also they are doing the traversal with the pre-order. The binary final tree built shown in the input output. Okay. Input output, they are giving just what how many numbers, how many nodes the particular tree, and list the elements. Performing right left rotation at 5. Okay, if the tree is not balanced, we have to do this. Okay, so 3 rotation they are done here, and after complete tree is ready, all the elements, all the nodes are in the balanced manner, then we just traversing the tree in the pre-order manner. Okay, this the things this program going to implement. So create a node. Just checking the greater value they are using on function, and the height. You have to find the height, right? For balancing factor, we should know what is the height of the left subtree and right subtree. For that, they are using one function. If n equal to null, return 0. Otherwise, return the what n of height, particular node height of the particular node. Okay. If the height is the balancing factor is should be in the it should be in 0, 1 or -1. Okay, the balancing factor is 2 means what is the meaning? For a particular node, we are calculating balancing factor. The factor is 2. Then what is the meaning? It may be what rotation is students. Yes, LL. Okay. The balancing factor 2 means what is the meaning? How we can calculate the balancing factor? Left subtree minus right subtree. So when we get the positive integer in the left side, we are having the elements, then only we get the positive integer. If the elements, if a particular node is having the balancing factor is minus 2 means what is the meaning? The elements are arranged in right subtree, right skewed, particularly in the right skewed. Then only we can get the balancing factor as minus 2, right? Okay. For that, we have to perform the LL means right rotation or RL means left. Like that only here the system going to find. Okay. We know manually. Now we are making our system to do this process. Okay. Create node is nothing but just creating one node and assigning the values. Here another one variables also used, that is node of height. If one node created, the particular height is 1. Like that, if it is in a root node, then it starts with the height is 1. Like that they are assigning. We can go with 0 also, no problem. We will see the right rotate and left rotate in after see the functions. That means the next one is we will see finally this one. Okay. Before that, we go with the get balance. We know balance factor. How we can do height of left subtree minus height of right subtree, right? This is the balance factor. And insert the data. How we can insert the same procedure, right? The same procedure. Node equal null means create the node. Otherwise, the data is less than node of data inside on the left subtree. Otherwise, in the right subtree. Else, return the data. Okay. If this is for root equal null and root less than data or greater than data. Greater than data means right side, it's left side. Otherwise, both are equal. Okay, this is the meaning for the insertion. And once you inserted, okay, each and every insertion you have to check with the height node of height equal to 1 plus max of this is no this is what means how we are selecting the height of the particular node. We are just taking the longest path, right? For the particular node we may have two or one or two ways to reach the leaf node to root node. We have the way root to leaf is many other way, maybe more than one. So we have to select the longest path. That's why we are giving here max of height of left subtree, height of right subtree. Okay. And plus 1. This is just incrementing the height after inserting. Okay. And get balance here stored in the case of balance. Okay. Based on the balance only we are going to the going to implement the rotation. Okay. For example, see here the balance is greater than 1. Greater than 1 means what is the meaning? Greater than 1 means what is the meaning? The balance factor is greater than 1. Then what is the meaning? Students, for the particular any node you can take, for that particular node the balance factor is greater than 1. So what is the meaning? How the elements are arranged in the particular tree, which rotation we have to perform for that particular node which is having balance greater than 1. Please think and tell me. Yes, LL. Okay. Is it clear, everyone? The balance is greater than 1 means it may be 2, right? So, the balance factor 2 means what is the meaning? The elements are arranged in the left skewed LL. Okay. And data less than node of left of data. Particular data is, okay. Now we are going to insert the recently inserted data is less than node of left of data. Okay, node left and data. Then what is the meaning? This is the meaning for LL. Okay, the balance greater than 1 means it is denoting L rotation, and again it is lesser than the left data mean, then this is also L. So it is for this function is for LL rotation. So LL means we have to perform the right rotation, right? L, it is in the form of LL. Left is skewed, so we have to perform the right rotation. How we can do? is here only they are calling the above function, that is right rotate. Okay, performing the right rotation at the particular node. Okay, node of data, just returning the particular data, and calling the function as right rotate. What is mean by right rotate? Here they are defining. Okay, this is the right rotate, we'll see. Okay, and okay, this is for what? LL rotation. The same function did here only. See here, we'll see next, we will see this second function. Okay, this is the first function, this is the first rotation, LL rotation. Here we come up with what? Balance is greater than 1. This is the meaning that the first to start with the L, and data is greater than the root of left of data. Greater than means it goes to the right side, right? Here see this condition, this data is less than node of left of data. Here data is greater than node of left of data. What is the meaning? LR rotation. Okay, this is for LR rotation. They are again calling the function as LR rotation. Means what is the process, how we can make the rotation, how we can make the particular tree is balanced. This is a double rotation, right? So we have to make two rotation. First one is the left rotation, and again one is the right rotation. Is it clear? Is it clear, ma? This is the double rotation. So we need to perform two rotation. This is LL, this is LR. And here please come with the second condition. If balance is less than -1, less than -1 means -2. Okay, if it is a -2, then it denoting the particular node in the right skewed. Okay, right subtree. So it is right. Again, data is greater than node of right of data. What is mean by that? This is also again defining the R value. So this is RR rotation. Is it clear, everyone? The balance is less than -2. Sorry, less than -1 means, I mean, less than -1 means it may be -2. -1, -2 means the particular nodes in arranged in the right subtree. This may be the right skewed. Okay, so this is called R. Again, the particular data is greater than means again R. If it is greater than, we have to place the particular data in the right side, right? So it is called RR rotation. We have to perform the left rotation for that RR. Okay. Again, calling the function left to rotate. The fourth condition, I mean fourth rotation, which one? LL. We have seen the LL and LR and RR. Now we are going to see the RL. Okay. The first condition R is for balance less than -1. And data less than node of right of data. This is less than, data is less than. So we have to make it is called L rotation. So RL rotation. We have to perform RL rotation. For that we have to make the first right rotation, then left rotation. Okay, this is the function. Okay, and print the pre-order. How we can, again the same procedure, recursive function used to print the elements. Once the tree is ready, then we have to print the elements in pre-order traversal. Okay, in main function nothing, that we just calling the function. Now we are going to see about how they are doing the left rotation and right rotation. For a single rotation we just make a single rotation. For a double rotation we have to make two rotation. First we go with the left or right, or if it is an RL then we go with the left and right. LR means we go with the R and L. Okay, so based on these two rotation only we are going to implement the left rotation and right rotation. Okay, assume that I will go with one diagram, then it will be clear for you. Wait. For example, if it is an we need to make a right rotation, means that is a particular T in the left skewed, right? Then how we can do? Any idea? We'll have examples, right? We'll go with that. Already we have explained more. Which one? This is going for right rotation, right? Right rotation means the elements are placed in the LL. Okay, how we can make the rotation here? The middle element should come in the root and left hand child. Okay, just make the right rotation. This the tree is in the form of LLK, so we have to make the right rotation. Okay, is it so? So right rotation means the elements are arranged in left skewed. Okay, we are just passing one node y here, okay, where I can insert. Okay, like that we are going to do. For This may be the root node, assume that, and x is the, okay, this is the root node, y is the root node. Here they are doing the process. How they are doing, I'm explaining. This is the root node, and x is another node. This is placed in the y of left. Okay, y of left, and another one node temp. The name is temp for that particular node. So it is placed in the x of right. So root node is the y. Okay, in that particular program they are explained the root node is a y. Okay, and x is the left of the particular y. X is the left of particular. I'm going to insert another one element that is also lesser than the particular root, means this case. Okay, if they are placing here, then how this is the LL case, so I have to make the right rotation, right? So how they are doing, the x will come in the root. Okay, the y is placed in the right shell, and another one element, which element we are going to insert now, that is placed in the left shell. Okay, this is the left rotation, right? So sorry, right rotation, right? So we are going to do like this. Again they are explaining another one concept also, that is what, if the root node is y, okay, the element x is inserted in the left child of particular node y. Okay, this way. Okay, this is another one node. Okay, then another one variable temp is there, that is maybe in the form of here. Here also one node is there. Okay, here also one node is there, but it may be like z. Okay, I can say this z, this is x, and y, this is y. The root node is y. Now I'm having one element, that is temp. Okay, it is placed here. This is called LL. So I have to make the right rotation. How we can do is, please tell me anyone, which element is come in the root node. This is the temp. Please anyone. In this case, this is the root node. This is y. The left child we are having the element as x. In the left of x we are having the element as z. Again the node x having the right child as temp. Now I am applying the right rotation. Tell me which one comes in the root node. Is anyone, which one come in the root node? Which one come in the root node, and which one is the right child and which one is the left child? Yes, please. Y is left. Okay. Okay, Mika. Then what about x? What about x? X in root. Okay, x in root, and y in the left child of particular x. Okay. Is it? What about is it? What about others? Respond. Please respond me. In this example, x is the root. Okay, after the rotation, x will be the root, and y is the left child of particular x. And what about z? And temp, please. Oh, discarded. Okay. This is the root node. This is the left child. Okay. And this also again another one left child. This is another one right child of x, that is temp. Okay. If we are having like this, how we can do this process? The x will come in the root. Okay. And for this x, y is the right side, right? So I can place the y in the right side. Okay. And z is the left child of x. So I can place the z here. Okay. Z here. Okay. What about this temp variable? This is in right side of x, right? We have to make the rotation. For example, this is the rope. Here we are having one variable. Okay, just we are rotating this way. Okay, this way we are pulling this the rope like this. So how the particular line will come? Please assume. Imagine this is the rope. Here one stick is there. Now I'm just sorry. Okay, this is the rope. I'm here. I'm having one stick, and I'm just doing rotation where this particular rope will come this side. Is anyone? If we are rotating, it will come like this only. So I can place the particular temp here. The temp is placed in the right child of temp is placed in the right child of x. So here it will come in the left child of y. Okay. This is the concept they are explaining. This is same the if no temp variable, no problem. We just make the right rotation as x in the root and y in the left, y in the right and z in the left child. If it is having any element, we have to do like this. Okay. This is the concept they are explaining that particular program. Where is that? Okay, this is the right rotation. They are explaining this the same concept what I am explained with the help of y, x. Okay, y root node and x is the left child and temp is the right of x. Okay, right of x and y is the and how they are swapping. Okay, how they are making the rotation this way. Okay, and again finding the height. Okay, once they are inserted, for example they are passing the if in the case of y, how the value which node which value we are going to insert, that element will come here. Okay, if it is in the place of checking with the condition, if it is in right rotation, which node having the unbalanced factor, that node value come here. Okay, make that particular node as a root and doing the right rotation. Is it so? Like this only we are doing, right? In the case of AVL tree, if the particular node, which one having the unbalanced factor, where for example here where the unbalanced factor is this node 11, so it may make the this particular node 11 as the root node, that is y, and this is x, this is another one variable. If the any element is here as a temp, like that they are assigning the elements and making the right rotation. The same procedure for left rotation also. Okay, you please check all those things and try to complete up to part 11 so far completed. Okay, please all of you What's the time? 2:40. Okay, fine. All of you, please log into a SkillTrack account and try to complete all the programs up to part 11. Don't leave the meet. I will make a note of all those things. Please don't leave a meet. I will try to explain. I try to give my best for you. Please go through and follow me also. Please try your own self. Okay, please try and go through in the net. Try to write a program by own. You don't want to keep the same program. You can go with any other concept, no problem. Plus, but you have to complete with the right concept. Okay, please all of you log in your SkillTrack account and try to complete up to part 11. Is respond me all are doing, or you go with SkillTrack account? Yes, students, respond me pa. Okay, please post a messages. Yes ma'am, those who are active in the meet. Yes, Abhishek, please post a messages. Yes ma'am in the chat box, those who are active in the meet. 1 2 3 4 5 6. Yes, others. Yes. Abhishek, Santosh, Rubaina, Manoj, Sujita, Yashwin, Lee, Meega, Ramya, Srinivas, Jashvita, Sandeep, Pradap, Nitish, Prithvi, Sanjay, Praveen, Rajalakshmi, Narasimha, Ritika, Nisa, Leela Krishna, Rajeshwari, Priyadashni, Teja, Renisha. Okay, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 people responded. Okay, fine. What about others? More 15 people. Are you in the meet or leave? Is others? Are you in the meet? For your understanding only, I am explaining again. Already these topics are discussed in theory itself. So no need to explain in detail. You have to go through all those this concept and try to implement. But I'm explaining. Please make use of it and try to complete. What about other 15? Not in the meet, just logged in and went out, right? Who's that other 15? Charan Reddy, not responded. Monish, no. Mugilen, Nisha, Nivedita, Pavitra, where are you? Sai Praveen, Aditya, Praveen Raj, Swaminathan. Yes, these people are not responded. Okay, Charan Reddy. Others, please, all of you complete up to part 11. Okay, up to part 11 explained. Please try to complete and update me. I will make a note of it. Everything I have noted. Why part 3 is not completed by Santosh and Sanjay? Is why not completed, both of you? Part 3 is not done by you both. Already I said, if you have any doubt, please ask me. I will check with my code. Yes, Santosh and Sanjay. Okay, please complete. Please complete and update me, both of you. Mm. Those one, anyone have not completed part 4? Anyone is there? Is students? Anyone? Anyone is there? Part 4 not completed? Okay, sorry, Praveen. What about Kiran? Kiran and Isa? Both are not at, completed. And Rohit, Sakti Charan. Yes, what about you guys? 4 people not yet completed the part. What? 4 is Sakti Charan is there. Rohit and Isak already said, right? Okay. Kiran. Kiran, what about you, Pa? Are you in the meet? Kiran, Sakti Charan, and Rohit. Sakti Charan not in the meet. Okay. What about Rohit and Kiran? Rohit not available. Isak, please try to complete soon and update me, Isak. Suganya ma'am.
Yes, ma'am.
Ma'am, some people not in the meet, ma'am.
Yes,
Please.
ma'am. I'm trying to call them, ma'am. I saw that I'm trying to call them. But few
Okay,
of the
ma'am.
members are not reachable
If
for
they
me.
are not joined, please make us absent, ma'am.
Yes, yes, yes. I told them already, ma'am.
Okay, ma'am. Isak, try to complete Isak part 4. Is part 5. Um, anyone is there? Not completed part 5. Yes. Jashvita, what about you? Jashvita and Ritika. Then Kiran. Again Kiran. Not done. Sakti Charan. The same people. Shakti Charan. Yes, what about you, Jashvita and Ritika? Yes. Permutation only bending. I'm doing that one. Yes. Why you people taking this much time? Already I have said na. Please complete by soon. Already I have time for you. Hmm? Okay, Jashvita, try to complete that also. Permutation. Sorry, what is that? Any one of the program in part 5. Yes, Ritika and Jashvita, please try to complete and update me. Part 5. Yes, part 6. Anyone not done? Part 6. Is Soy Praveen not done, Vaipa? Soy Praveen and Nisha, Nivedita, Santosh, Praveen, Pradap. Many people is there. Priyadashini, again Kiran and Sakti Charan. Yes, why? Is all of you try to complete? Is Soy Praveen? Why? Nisha, what's the problem? Compiling error for Soy Praveen. Array implementation ADT. Okay, pa. Try to rectify Soy Praveen. Yes, Nisha, what about you, ma? In 7 also one is what's your problem? Any doubt you can ask your friends, otherwise I will guide you, Sai Praveen. Nisha, what about you? Nisha is there? Nisha not available. Nisha is there, right? Respond me, Nisha. 461 program pending with some error. Now, yes, which program and which error you got? Is which ADT? In part 6, which ADT? List ADT. Okay. Which error? It seems. Yes, Nisha. Test case failed. Okay, ma, try to rectify. You please discuss with your friends and try to complete. Even though not possible, please update me. I will help you. Is Nivedita? What about you, Nivedita? Why you not done one program, Nivedita? One program in part 6. Is Nivedita? Is one program in part 6. Why, ma? Why not done? Which program? Array implementation is easy, right? If you're having an error in a list edit or list implementation, it may happen in data structures frequently. Then no problem. Array implementation is easy, right? Why you are not done? Nivedita, try to complete that and update me, Nivedita. And Santosh, which one, Santosh? Is Praveen QADT. Okay. Okay, Santosh, try to complete. If you have any doubt, ask me. I will help you. I will check with my code also. So, Praveen having. Yes, Praveen, you have to complete two programs. Only one program completed in part 6. Why, Praveen? Not done or any error you received? Okay. When you can complete this program, Praveen? When you will get your laptop? Yes, what about you, Pradap? You also need to complete 2 programs. Is Pradap Priyadashni Monday? Okay, once completed, inform me, Priyadashni. Praveen, as soon as possible, please complete. Kiran Sakticharan. Okay. Yes. What about part 7? Anyone is there? Not yet completed. Part 7. Part 7. Mohit is not done. Prithvi. Again, Sai Praveen. Praveen. Kiran. Isak. Nisha. Not yet started. Nisha, why? What's the problem? Nivedita. Ma'am, today I will send my code. Ma'am, I could not rectify on here. Okay, which program, which part? Please tell clearly and send your code. I will check, Mohit. Which part, which program, like that. You please send me. I will check with that code and update you. Is Sai Praveen? Is one program is there? Which one, Sai Praveen? Link list implementation. Okay. What problem? Is Mohit seventh part okay? Which program? All the things. Only one, right? Is which one? List edit. Okay, please you please send the code to my mail. I will check and update you, Mohit. Compiling error. Okay. compiling error may it may happen in the segmentation only. You may check with your list implementation, start node or null pointer. Otherwise, the malloc function. In this place, you will check and check with that. Check and try again. Ritika completed part 5 permutation. Part 5. Okay. Okay, ma. Mohit, your mail ID. Mohit and Sai Praveen, I will send. Mohit and Sai Praveen, what is your mail ID? Part 7 link list edit, right? Okay. Is Prithvi, what about you? Why you not completed? Prithvi is there? Monday. I will give you time up to Sunday. But please, all of you try to complete all the programs within Sunday. Okay. Otherwise, I have to make any changes. Okay, I have to make any steps. Need to have difference between the people who are done in time and you, right? Please, I give another one chance for you. Try to complete within Sunday. Otherwise, I will make some steps. Okay, all of you, please complete by Sunday. Those who have not completed, if you are done, if you have any doubt or error, please ask me. I will help you. Otherwise, you have to complete within Sunday. Sunday I can give time. Within Sunday, you have to complete up to part 11. All of you, don't forget. Okay. Within Sunday, you have to complete up to part 11. Okay. Then Nisha, Nivedita, all of you, please complete the part 7 and update me. Nisha, Nivedita is not yet started part 7. Why, ma? Why, Nivedita? Not yet started your part 7. Need to complete all 3 programs. Why? When I'm keep on following you people, then only you complete, right? Definitely, I'm saying within Sunday, please complete up to part 11. Otherwise, I have to take some steps. I mean, need to go with I will go with the mark reduction or need to report higher authority, anything it may be. I need to do something. So you people, please, all of you, try to complete up to part 11 by this Sunday. Okay? Respond me, everyone. Try to complete up to part 11 by this Sunday. Okay. I will check. Don't forget. Frequently, I am going to watch you. Try to complete and update me. No problem. Is Priyadashini, Praveen Raj, Rohit, Rakshini, is Priyadashini not yet started part 7. I don't know why. I'm regularly telling you people try to complete all those things. Praveen Raj, Rohit, Rakshini, what about you? Why not yet started part 7? Is Rakshini is there? Okay. Please, all of you, please try to complete in part 7. Mohit, Prithvi, Sai, Praveen, Isak, Nisha, Nivedita, Pradap, Priyadashni, Praveen Raj, Rohit, Rakshini, Kiran, Sakti Charan. All of you, please complete and update me. Part 8. I gave assignment and many project also, right? Please try to complete in time. Then only I can give marks for you. Part 8 already I have said in the class. Okay, that time I explained and tried to complete. Ask you people to complete, but some people only completed. Not yet started. Mohit, Kiran, Teja, Prithvi, Miza, Isak, Pavitra, Sai Praveen. Part 8 not yet started. These people. Nisha, Nivedita, Raj, Lakshmi, Praveen, Pradap, Priyadashni, Praveen Raj, Rohit, Ritika, Sylvia, Rakshini, Rinisha, Santosh, Sujita, Swaminathan, Sakti Charan. You please, all of you, complete all those things within Sunday. Okay. I will expect your full cooperation towards our lab exam, lab semester. Okay, for that you have to complete all these exercises. You have to make a record, right? For that you people, all of you, complete. Okay, Mohit. Part 8. No, sorry, Praveen, you have to complete up to part 11 by Sunday. Students, are you doing? Anyone completed? Okay, Ishwan, Sanjay, what about you others? Okay. Anyone completed any one of the program? Okay, thank you. Thank you for your response. Students, don't forget, please try to complete all the programs up to part 11 by this Sunday. Okay, I will check, I will regularly monitoring your skill track status. Okay, now the time is over, you can leave. All of you, please complete assignment and mini project also in time. Okay, thank you, Pa. Thank you so much, all of you. You can leave now. Yes, thank you. Thank you. Thank you, all of you.